Hey, Zach here. So I recently smoked a rod bearing in my JZX100. So that's a VVTi 1JZ in that car from the factory. We're gonna build a stroker. So I'm gonna build a 3.4 bottom end, so 3.4 liters, so almost 30% displacement increase, which is gonna be fantastic. My secret JZ motor, so you can get it for $300 all day long. You know, importers are asking $7,000, $8,000 for VVTi 2JZ when your local friendly IS300, GS300, SC300 has one on your local marketplace or Craigslist for about $300, depending on condition and quality. So we're going to use just the bottom end of this motor. We're going to use this, actually this cylinder is going to go on something else. We're going to use the 3-liter block and none of the rotating assembly in my JZX. So what we're going to do today is tear it down. I'm going to show you what I look for when I tear down a motor. We want to make sure it's not had any major mechanical failures, all the gaskets are sealing, doesn't have any rod bearing damage. This one's a little different since we're using different crankshaft rods and pistons. We're not keeping much, but we'll still check it, make sure there's no red flags or damage to the block itself as we tear it down. So first thing we're going to do is get it on a stand. This is obviously out of an automatic car, most of them are. So we've got our flex plate to get rid of. We want to get this off before we get it on the stand, as well as the retainer for the rear main seal, because once you get it on a stand, you don't have access to this stuff. So we want to pull the pan and the crankshaft. It's much easier to get all this stuff off beforehand. A little life hack here, literal hack. When you get an engine stand, you know, using the Harbor Freight quality like most people are, they make these standoffs about like an inch, inch and a half long, which if you're using your regular transmission bolts, you're not going to get any thread engagement. So what I do every time I get a new engine stand is just take a Sawzall to it or an angle grinder or whatever. Make sure we've got plenty of thread engagement. So we just shorten them up a little bit because there's no real conflict here with the back of this. We don't need a lot of depth. So I trim them up. That way I don't have to go on ECUMaster or a hardware store and buy oddball specific long bolts. I just trim this to match. So what we can do first is yank this flex plate and we'll go from there. One thing to note, if you're going back to an automatic, a lot of these there's this ring on top of the flex plate and some of them have this spacer behind it. You need to keep all that because there's a stack up. So you want to save those since this is getting a manual flywheel. These bolts are too short anyway, so this all just goes in the scrap pile. Next to come off is the rear main seal retainer. We will be reusing this obviously because we need a rear main seal. I'm pretty good at spotting all the fasteners on a JZ motor because I've done dozens of these little guys, but it is a super safe bet. Keep your stuff organized to keep some small plastic baggies around and a Sharpie and label which ones are which. And these don't have to be super tight. We're not trying to hold the cylinder head down to withstand combustion pressure, right? We're just wanting to hold this motor tight. The top two are more critical because you've got a lot of tension in those. So you flip the motor over. All right, now we've got it on the stand. You want to make sure there's no oil in it. Well, you want to grab the whole dipstick maybe. Tell you what, there we go. Looks like there's just a little bit of oil left in this. So I'm gonna grab a pan to put underneath it and drain that while we're taking the valve covers off and starting at the top of the motor. So I grabbed the wrong socket. I was expecting a 14, which is what the factory drain plug is. Somebody's put a 19 on here with no crush washer, which would explain why it was leaking, because there's no... Yeah, you shouldn't have that in your oil pan. If you want to look here, this is where your turbo drain would normally go. On a GTE motor, there'd be two M8 by 125 holes here. This would be drilled out. So you can actually drill that out, or you can just weld the dash 10 fitting to this pan to convert that to the GTE spec. But this is the GE motor, because obviously not turbo. Another smart thing, Joe, I've seen probably 20 people online ask what this little guy is for. It's actually a coolant drain. So let me throw a socket on that just to show you. It's a 14 mil. And you can crack that, and any residual water in the water jacket will come out once you loosen that. So you can see it's just spilling out a couple of drops. That is one thing that's super nice when you have an engine on the stand. You know, if it's been in a motor or in a car recently, it's gonna have a ton of coolant in it. So it's just one more thing. Once we flip the motor over, the rest of it's gonna come out. It's nice to get some of that out here and let that drain while we're working on other parts of the motor. Yank the AC compressor because it is not to be on the motor while we're working on it. There's one more on the bottom that's covered in goo. Again, if you're not familiar with all the lengths of these fasteners, I would grab a piece of cardboard and punch them through holes in the cardboard, oriented the way they need to go back on, or you can put them back in the part that you just removed. That way we know where everything goes. Got this bracket. This is for the power steering pump. That one has a bolt hiding under there as well. Just a note, if you're ever removing one of these motors from a car and you want to leave your AC charged, what you would do is grab an inverted Torx. Once you loosen all the bolts to that compressor, grab the inverted Torx and grab this little stud. So if you pull it out of the compressor before you remove the compressor, you can leave it in the compressor just hanging and then drop the compressor down to the side and lift the motor up and out without disconnecting your AC and having to recharge it later, which is a huge time saver and money saver. We're gonna pull the valve covers off. Fun fact, I believe all the GE valve covers are actually magnesium and not an aluminum alloy. So the GTE valve covers, all the turbo motors, you can either weld on AN fittings for breathers or like radium makes a really nice press-in fitting. But the GE covers, you try to weld magnesium, at best, it's gonna pop and crack after you weld it. At worst, it's gonna burn down your shop. I'm not keeping these, so I'm not afraid to be a little heavy-handed with the removal. These old gaskets get nice and sticky and crusty in their old age. What's nice is if you look in this motor, looks like these have been replaced before. Somebody put silicone on these gaskets, which wouldn't have been there from the factory. So it's been resealed before, but there's not any scum. The thing looks like it got regular oil changes, or else there'd be a lot of gook in here, but the cylinder head's really pretty clean. No scoring on the camshaft. Yeah, it looks really in reasonable shape, which is nice. All right, now the valve covers are off. I'm gonna start stripping everything off the sides and the front of the motor so we can get the cylinder head ready to go, because we can always pull the oil pan off last. So we'll get the top end done first before we flip the motor over. So I'm just gonna start grabbing random accessories. They're all gonna be mostly 10, 12, and 14. So I need a few sockets here. I'll start getting them off. Water neck. After that, I'll grab the coolant line that goes around the block that attaches to the water pump. There's no real need to remove all the front half of the water pump or remove the water neck outlet. You can remove this bolt here that holds the crankshaft position sensor. If you have an earlier GE motor, you're not going to have this sensor. This is only on the later variants with variable valve timing, or I think 96, OBD2 might have added that. But you can leave the whole water pump assembly together. And once you get the timing belt loose, you can actually grab all the 12mm bolts from the front, and it'll come off as an assembly. You don't need to separate it because they never really seal up right after you tear them apart, but we won't be using this anyway because the GTE pump is different. This is the timing belt tensioner. These bolts are specific as well. They have a nice little size shoulder on there to help align it as it gets installed, so it's important to keep those together. There we have an assembly with the water neck, water pump, front and back half, coolant outlet, everything. I'm going to toss that to the side. Now we're going to start getting our oil pump off, which we can't remove entirely until the oil pan has come off, but I'm going to get these Now, basically got the tool in hand. It's easy enough to do so. We need to pull this crank sensor off. That's a 10 millimeter. One thing to note, this is a really common failure point on JZ motors. I just loosen this. It's an inverted Torx. Quite honestly, you can grab out some vice grips and just loosen it up. This is the alternator lower stud. If people leave this on and start moving the block around, say you're taking it to and from the machine shop, you're putting it in the car, there's so much leverage here, it'll break this ear off the block and then you can't mount your alternator. I saw somebody did recently come out with another bracket that kind of grabs a couple other points, maybe goes up here to replace that if it breaks off, but if you can at all avoid it, it's so much easier to put this back once it's in the car. It doesn't need to be tight, you just need to bottom it out a little bit, and then you can throw the nut on the front, tighten the alternator, and it's not going to go anywhere. But super, super safe bet to pull that before you move the motor around. And one important thing to note, so you don't break your trigger wheel, there's a retaining tab. Let me pull this back if I can a little bit so you can see it. If you look from this side, it's supposed to keep the timing belt in place if it ever gets some slack in it. If you don't remove this and try to pull this gear off, you'll break teeth off of it. On the earlier 12 teeth sprockets, the back piece is just pressed on, it's not welded. You'll pull that off and bend it. These are a cast or a forging, and it just snaps the teeth off and you have to replace the gear. So whatever you do, make sure you get in here, pull this little guy, pop this tab off, and then you can remove your timing gear, which looks like it's loose and ready to come off. Sometimes they're a little tight, you need to use a puller on them or apply a little bit of heat to free them up. It's a little warm. I was going to pull this gear off. I just noticed this may actually be why they pulled it out of the car. Somebody damaged this already. I haven't touched this side yet. I was working on the other side, but somebody already damaged this trigger wheel. There's a tooth missing and it's bent up from the back. So I'm not even going to bother to go get my puller. I'm just going to keep tapping this with a hammer until it comes off and being very gentle so don't damage the crank. But again, I'm not even using this crank, but I'm going to keep it as a good spare for a 3-liter setup. But just going to be really gentle and kind of work this off the end and then throw this away before it gets accidentally put on another motor because it's no good. So if you're going to use a puller on here, you need 2 very long M6x1 bolts. That's the trick, is finding a long enough M6x1 because you have a lot of reach from the front of the snout all the way back here. It's just a simple 2-bolt puller, like a steering wheel puller, and then you put the conical portion in the middle. Be sure not to damage the threads of the crank. They don't start until about a ½ inch in. But these can be kind of obstinate, so you may have to let it soak overnight, apply a little heat to it. Just make sure you don't put so much heat in it that you kill this front main seal. But look at how, like, what clown worked on this. There's silicone smeared all over this front main seal. So some idiot's been in here before, didn't know how to put in a front main seal, just smeared silicone everywhere. So it's going to be an interesting motor to take apart because the outside's been messed with a little bit. We saw the valve covers, and here this oil pump looks like it may have been replaced. It doesn't look like Toyota sealant, so I'm kind of curious to see what we find inside. So we got that timing gear off. The rest of the oil pump bolts are coming off now. We've got more underneath. Just be aware of that. When we start pulling the pan off, we'll pull those off. You can pull the oil pump off after the pan comes off, but I'm just doing these while they're accessible right here. Make sure I've got all of them out. One more being sneaky. And again, pay attention to the lengths because these are all from the oil pump, but there's 2 different lengths here just in this hand. There's more on the other side. So we're good to go there. And again, while I'm working on the top, I'm just looking at everything I can remove, so pardon me if I'm a little disjointed here. I just keep seeing stuff that's easy to grab. This is the oil level sensor, and this one somebody destroyed. I'm not going to use it because the JZX might have a slightly different pan. Even if it doesn't, it has a good sensor that's not damaged. These do tend to leak. There's an O-ring you get from Toyota that may not come in the engine gasket kit. Then pop these off. Just use the flat tip of a pry bar to kind of break the seal, but let's use our gasket scraper here to pop the corner. Doesn't take a lot of force. It's a little float style sensor, and there's also, I believe, an oil temp sensor in here. I think there's a thermistor, if I'm not mistaken, because these go to the check engine light, but I think it's just level. I could be wrong. So working on this side of the motor again. This one's already been loosened. This is the oil feed for the VVTi solenoid. VVTi solenoid is, VVTi basically rotates the cam independent of the other camshaft and the crankshaft. So you're advancing retarding the inlet cam. It's got this neat little basically plunger inside that as it moves forward, it goes on these diagonal splines on this phaser and it shifts the cam angle, and that's fed from oil pressure from the block. So this hard line goes from here up to here. There's a filter in here that's actually missing on this engine, if I'm not mistaken, which is a really common pain point on these, because if it gets clogged up, your VVTi doesn't work, because you're not getting adequate oil feed through the block. This one's missing because I think we stole it for another car. But be sure you keep all this hardware. I would replace the crush washers. Make sure you don't bend it when it comes off, because you want it to go back on exactly as it came off, and save all the hardware separately. Make sure I don't drop my crush washer here. So that's the top banjo bolt that should have a filter pressed in the end. It's the retention nut or bolt. And then for the hard line, that is a, looks like it's 22. So I'm gonna do the bottom. And if you want to put a VVTi head on a non-VVTi block, you've got options. Because all you need is oil feed and the solenoid. The solenoid's attached to the head. I think impact down. So here's our hard line banjo bolt. So that with our other hardware, I'm gonna pick up my impact that I dropped. I'm gonna leave this washer on because peeling it off, I'm gonna do more damage, getting dirt all in there. But if you have a non-VVTi block, in the same area is an 1/8 inch, I think it's British pipe thread that feeds the oil pressure sender. Powerhouse Racing and a couple others make an adapter from that thread to something usable, and you can get a braided line that goes up to a banjo fitting here. So you can adapt a VVTi head to a non-VVTi block. It's really not a big deal at all. You can also use that same spot as oil supply for a turbo if this is a non-VVTi, or excuse me, a non-turbo motor. You can use that same oil supply to feed the turbo. I'm gonna make myself some room and remove the upper water neck. It's got 3 fasteners on it. They're all 12 millimeter. For the sake of simplicity, I'm gonna leave the coolant line attached to it. I'm just gonna pop it out of this bracket. One thing I like about JZ motors, they're modern enough, they've got nice steel gaskets everywhere, so they don't really require a lot of cleanup. Like you could just wipe that down with brake cleaner and put it right back on. It would seal up fine. I'll pop my fasteners in there. All right, back on this side of the motor, we've got a couple more things to remove. These are our 2 factory knock sensors. We're not using these. We're going to use WHP sensors. It's our in-house brand. It uses a Bosch donut style sensor and a custom stud, and they are flat response sensors. These only ring at 1 frequency. So if you change the displacement or the compression ratio or whatever on the motor, anything that changes the sounds it makes, you don't get useful results from the knock sensor anymore. I'm gonna go caveman style and grab this one with a wrench. Removing knock sensors with a caveman wrench is totally fine. When you install them, you want to torque them to the exact torque spec because it changes the sensitivity. On ours, I think the spec is 11 foot-pounds. Stock, I can't remember. But ours comes with a nice little adapter stud. Make sure your pad is clean here. This is bare metal for a reason. So make sure you clean that off and you got good bare metal contact between the sensor and the block because it's acoustic. It's like a microphone listening to what's happening in your engine. But these are getting thrown away because they're not useful in an aftermarket application. And next up, we've got our pressure switch, or oil pressure switch for the sender. That guy's little British pipe thread. I think it's that same size, yep, for the oil filter housing. This may be messy. On this one, since it's a non-VVTi, or excuse me, non-turbo motor, there's no oil cooler here. It's just the adapter straight to the filter. On turbo motors, you'd have a sandwich plate here. That's a heat exchanger that runs coolant through, which is great because it actually helps bring the oil up to temperature faster. So a lot of wear on engines is from cold damage, from not being warm enough. The oil can't flow as well. It's not the right viscosity for what it's trying to do. So getting your oil up to temp as quickly as possible and then maintaining that is really critical. If you were doing drag race only, you're probably fine without an oil cooler, but for my stuff, I always like to use the factory heat exchanger if I can, because it's just a benefit. That O-ring is crusty as can be, unsurprising with the age of this motor. Just gonna peel that guy off and get him out of the way. And now we can start removing motor mounts off each side. These are all 14 millimeter. Just to give you a reference, that oil pressure sensor and the oil filter housing, that was a 24 if I'm not mistaken. Let me grab that just so I'm not lying to you. There it is, going into 24. Yes, it's 24 millimeter. Alright, again, this is a non-turbo car, so this heater hose is a little more simplified. There's not as many connections on it. It was the 2 connections on the water pump and 1 back on the block. And I'll set this guy aside because I don't think it's the same one as the JZX, so we won't be reusing it. We'll keep that just as spare parts. What I am going to do though is start to blow off or brush off some of this dust and grime because I don't want it in the ports. Last thing you want to do is clean up the outside of a motor and fire it up. You get all the sand and debris that goes in the motor if you weren't really thorough about cleaning it, because you can clean it all you want in the world, but if it gets stuck on top of that valve, it's going to be really hard to see or get out. All right, we're going to pull the cam gears first, then we'll pull the timing cover, and again, more silicone that should not be there. So that's the cover for it, and I've got it looks like a 10 mil hex in there, but yeah, some fool siliconed this junk on. This way, don't put silicone on stuff. It ends up loose and inside somewhere that should be very clean. May have to just replace this whole gear because that's not supposed to be there at all. So anyway, let me get a 10 and we'll yank this guy off. There's someone just boogered up this bolt. Here goes the 17. Loose. And your cam gear should swap right off. There we go. Alright, so if you're unfortunate and some knucklehead's been in this motor before doing dumb things, you break your Craftsman 10mm trying to get the camshaft bolt loose because it's too tight. So you've got a crescent wrench on here trying to hold the cam in a normal world. That would be enough oomph to hold the cam while we loosen this guy. But it's being really dramatic because somebody over-tightened it. So I may go caveman style and just ride off this gear because somebody's been in here, they put silicone in it. I'm just going to buy another one because I don't trust this one. So we're going to have to get a little aggressive with this. So here's what we've got now. So we broke our 10mm socket, so I'm using a traditional Allen wrench with the handle from our transmission jack. Since I'm going to have to tear this apart and rebuild it anyway, there are seals in here that you don't want to overheat. I'm going to use our torch and heat up this bolt in an effort to get it loosened up because somebody just gorilla tightened this thing. I'm going to tear it apart and rebuild it if I even keep it, so here we go. So we're making an ornate decorative Allen wrench here because this thing has just been, you know, crushed past belief. So we're gonna try to remove the outside portion of the gear, which I don't think it comes off that way. I've never actually torn one apart. Worst case, we're gonna pull the cam cap up and off, pull this one up and off. We're gonna lose this backing plate because it's gonna be stuck around this cam and cam gear. These are stock cams, we're not keeping them for anything. I'm just trying not to destroy the head, but we have to get the cams out to get the head off. So we're gonna try removing the outer ring first. If that doesn't work, we'll just pull all the bolts we can get to. And yeah, it should be interesting. So here we go. Yeah, just as a visual, here's how much the cam actually phases on either stop. You'll hear some cars with big cams in them when they've got to put standalone on them, they'll rattle at idle. It's actually this bouncing against the stop because they haven't given enough steady state duty cycle to keep it off that mechanical stop at idle. But that's how much phasing you have. So I've loosened everything up. I don't know what's going to come off, if anything. Oh, there we go. That cover's going to come off. And that's the inside of a VVTi cam gear. So those are the splines I was talking about. O-ring seal inside. And we're just going to lay these parts out because we're not keeping these at this point. This is a seal inside that would fail and leak. But there's the mechanism. There's basically a plunger that forces the cam gear out and rotates the cam. There's the phasing action right there. So we've reached almost the limits of our stupidity. So we started drilling this bolt out, and going up in bit sizes was a little tedious. We grabbed the step bit, and we made a perfect impression of a Christmas tree bit inside that bolt. We kind of bottomed out and reached the end because it has to drill like the whole surface area of the bit up to here, so it's not really moving quickly. So I'm going to get a smaller pilot and get the pilot hole drilled out a little further before we tack it more. All right, we're operating under not normal circumstances, so we just used our Christmas tree bit and wallowed at that bolt until it actually broke the end of it off. And what it looks like is I don't think we really damaged anything on the cam gear itself, so it may be rebuildable. We did tear it apart, it needs to be resealed. But again, I'd feel safer just buying a new one since we're gonna use aftermarket camshafts, but that bolt is Dunski's. That was a waste of time, but at least we can get everything apart now. Look at that, slides right off. Ooh. Now it's reusable. That's our front cover. We can remove our front caps first. These are unique. And all of them are numbered. The nice thing about Toyota engines is that they number them for you, so you don't have to go back and manually number the caps. We've got very clear numbers on the top, so you don't have to sit there with a punch and mark it off. Obviously the intake and exhaust are visibly different because the intake gets the VVTi gear. Also, if you ever need to replace just your VVTi solenoid, it's just this one bolt on the top, and it actually slides out. This one's been removed already, but you got one retention bolt, and this is the solenoid, basically motor itself, which is a big coil with a plunger, and it diverts oil through all these passages here. So this one's pretty caked up. It would be worth cleaning and putting new O-ring on that if you're going to reuse it. We'll probably just buy a new one, slap it in, just because with aftermarket camshafts and much more valve spring, it's got an uphill battle. So I'm going to pull these front caps first, get them out of the way, and then we're going to loosen all of these kind of step by step. If you get too aggressive, start loosening one cap at a time, the force across the valve lobes can actually snap a camshaft. It's more common with aftermarket cams because you're using stiffer valve springs. But even with stock cams, we want to not break anything while we're in here. Ready? All right, one thing to note on the intake cam, this cap has 4 bolts. It's got these take a 5mm hex. What you should do when you're gonna loosen them up, there's usually enough goop and oil in that fastener. You want to smack your socket down in it to make sure it gets all the way down to the bottom and gets good engagement, because if you strip those, they're kind of a bear to get out. We remove the 2 front, they're loose, and I can just pry here on the front of this cap a little bit, and then get our cap assembly out all together with the solenoid and everything. One thing I do when I'm pulling caps, I pull the 2 bolts up and just pinch them by hand to hold the cap tight. And when I'm removing it, use kind of a dull pry bar so I don't scratch anything. And then you can just wiggle it off, and that keeps the bolts in place. You can take a look at the bearing surface, and you're good to go. Crack each of these about a half turn just to get them loose. Then I've got a speed wrench. And again, as I was mentioning before, you don't want all the tension on just 2 lobes right in the middle of the camshaft because it'll crack the casting. Loosen these off. This is probably the most tedious part of the whole ordeal, aside from drilling out the VVTi bolt. Switch into my speed wrench. What I'll do here is just do a turn each. Yeah, so you're looking for the caps to all be totally loose, and that's when it's safe to go and start yanking them one at a time. Might missed that one, there we go. And you can feel it too, you'll feel the tension in the bolts, and you can watch the cam caps rise up. Like this one still has tension. So I'm gonna start from this end and go down. Now that tension's out, this one has no tension. This one will probably have a little more. Once you go all the way down the row and you feel that there's no tension in them anymore, you can start removing them one by one. And I'll just grab my impact and start zipping them out, and we're good to go. That's our numbered set, ready to go. So just to show you guys what you're looking for, this is the intake side of the head, right? Intake manifold here, exhaust manifold here. This is the exhaust cam, and this says E2. It's got an arrow pointing to the front. So if you're paying attention, you cannot get these wrong. Exhaust meaning 2 from the front. So this would be E1, 2, 3, 4, 5, 6, 7. Arrow goes to the front of the motor, intake side, exhaust side, real easy. And lifting your cams out, there's no special magic. You might want to look at the condition of the seals. These were real bad because they, again, like the front main seal, they smeared silicone all over the front, which you do not do. And these are just going in the garbage, so I'm going to set them underneath the table. They're not good for our use. So I'm going to throw the cams back in now, just to hold the buckets in place. I'm just going to grab any cap, throw it down right in the middle. All the head bolts are out, all the washers are out, but I just don't want these buckets and shims going anywhere as I'm moving this head around. So I'm not worried about dirt because I just have these cams on the floor, because this head, if it ever gets used again, will be totally torn down and ported and gone through, but I just want something to keep everything in place while I'm messing with it. And then our head should be ready to go. So I'm going to take breaker bar, just carefully, I'm going to grab it inside one of the intake ports so I'm not going to hurt the valves. Rock it up, make sure that gasket's nice and free. I'm ready to pull that cylinder head off. Yeah, so I'm looking at it now and I see some rust down on the cylinder, which isn't ideal. Don't lose these dowel pins, those are important. One popped out. It looks like the gasket stayed on this side on the non-turbo motors. It's just a single layer steel shim. Looking for any signs of waviness or funkiness, and it looks like the head gasket was in fine shape. What worries me is I see some rust in these bores. They've been sitting for quite a while and had some water in them. Got some carbon buildup that came down, which isn't really a concern. So I'm going to spray it down with some penetrating oil and then start tearing this thing down. So what I'm looking for on these is any sign of mechanical debris, valves hitting pistons, any pitting from detonation. And it's turning really nicely now that I cleaned just that surface rust off the bore, but this thing will get overbored, so I just wanted to make sure there was no major damage to the bores. We're good to go now, so I just wanted to get some oil in there before I start turning over those rusty rings that have been sitting for quite a while. So it's time now, we're going to go and flip it over and take a look at the bottom end and see what we got. Alright, so we've got the motor flipped over. Now it's time to...
Of course, somebody done the oil pan.
Of course. The first bolt I go after has the oil pan bent into the bolt, so we're going to fix that first. Give me a little room to get that socket on. Let's see if that's enough. And I'm kind of curious the history motor, because these bolts have definitely been out before. Toyota didn't leave a mess like this when they built JZ motors. They wouldn't leave a bunch of excess gray silicone on the heads. So somebody's been here, so I need to measure the bore and see if it's been overboard. And then I'll know how much meat I've got to work with. If we're going to go bigger, which we need to clean up that surface rust in the bore. These are kind of tricky because you don't want to bend the panel a bunch, but you have to get something sharp between the sealing surface and the metal, the steel pan. I'm improperly using a gasket scraper to put some tension under that. And it's kind of a time-based thing. You can leave it there to sit and you'll hear the silicone kind of give and peel as you put tension on one spot, and then you just kind of move on to the next spot. Work it in like a wedge. You can actually sit there and hear it release and peel a little bit. You don't have to lean on it and pry on it at a time. You just have to keep working your way around and let it loosen itself up. See how much looser it's getting? Now we're good to go. That one didn't take too much. And once it's loose, I'll work my way around and just get it really freed up so it lifts off easily without bending it. We're free there, and that makes a nice little parts tray. And I'm going to look in here for debris in the strainer. That kind of gives you some history on the motor too. If there's a bunch of bearing in there, obviously if you got a store you got to deal with, but this one looks pretty clean, just some debris from gasket material, looks like, from some of the work that was obviously done on this engine previously. We've got 2 more for the pickup. I'll drop that down in there. Make sure you wrap the gasket to this. Toss that off in the sump. I'll put the fasteners from that in there with it. This guy in there. And then we get all the fasteners that hold the main cast pan in place. Doesn't really matter what order you undo these in. There's no magic here. We're just getting it loose. Those are all 12s, and then we got all the ones on the front already done. Those are the first 2 we did. So I'm gonna switch to a 14 for the rearmost ones. And then check and make sure there's none from the top. I don't think there are on GZ Motors camera, but there may have been one specific pan that had a couple that were hidden. If I remember right, there was one variation that had a couple that weren't obvious, because you don't want to start trying a big cast piece and then find that you didn't undo 2 fasteners. So I'm walking around doing a quick triple check, make sure I've got no fasteners showing, no loose studs, no hardware from the top. I've triple checked, ready to pop this pan off. If you look on the front of this motor, there's a really cool gap on the front between these ears on the block. They make great pry points to lift this pan up. So I'm just going to very carefully start lifting there, and you know, if something starts feeling weird, don't put too much pressure on it, but you can kind of lift and hold, and you'll hear the silicone release. It kind of like, it's almost like a chain effect. When you put some tension on the front, it starts peeling from front to back. So this side's nice and loose. I'm going to move over here. Just tap. Lift it up a little bit where I can pry on it safely. Then you can really just grab and lift it in the front of the pan. It comes off nice and easy in one piece, ideally. So I don't have to be super gentle with these. This isn't like a head where you want to release the torque evenly. Yeah, there should be no tension on the crankshaft. I'm looking around for my adapter at the moment. What I'm going to do is zap off the one main cap. I got it. We'll zap off this main cap and just see what the thrust surfaces look like and the main cap looks like. And then zap off one rod and see what that rod bearing looks like, just to get an idea what this motor is going to look like. In fact, I'll do 2. So we're not going to do a full teardown today, so I want to wrap things up. But this is enough to get it cleaned up into the machine shop. Yanking a couple more pistons and rods, you know, it's no more technique, it's the same old stuff. So we'll zip this one out. What I'm going to do with this to get it separated, I'm going to put those bolts back in so I don't mess up the threads. Just take the wood end of my hammer, knock it down a little bit. Oh, it's freed up. You can lift it back up. Pop these bolts out super easy. I'm going to set them, I don't think they'll go down there. Yeah, I'm going to set them here for safekeeping. Pop it off. Yeah, not really, not an indication of debris in there. You know, one little scratch, but for a motor with unknown miles, it's really even. There's no shiny spots. There's no trash that's gone through this motor a whole bunch. That crankshaft looks nice and healthy. No big scoring marks in it. So I'm really happy with the way that looks. So we'll check the main next. And again, this motor that we're building, we're not reusing the crank. But if there were damage to the crank, you'd be concerned about the block. And even though I'm not using this crank in this motor, it's always good to have an extra 3-liter crank around. And there are tabs. One nice thing about Toyota motors is that they give you a provision for lifting these caps. So you see there's a tab on either side. So you can get on here just gently and lift that main cap from either side. And it pops it up super nice. You don't have to beat on it or wiggle it back and forth. Again, you can use the bolts as a lever to kind of pick it up and hold it. Make sure my thrust bearing doesn't pop out. So on manual cars, dry starting on the thrust washer, you'll often see more wear on the back. This is auto, but really just a minimal amount of thrust wear. Again, that looks super, super clean. And this is what a clean factory main bearing looks like. It's nice and shiny. No trash or debris in it. All those factory lines are still on there. Looks super happy and healthy. So I'm really pleased that this motor looks this clean for how sketchy it was on the outside with all the silicone and bad workmanship. So I'm going to loosely throw this back together. All we have to do is remove the oil pump, remove the rest of these caps. We can yank the crank and rods and pistons, and we're good to go. And we'll get a better look at the bore once it's all torn apart. All right, we're going to drop this piston rod out the bottom. Make sure we got the bearing in there. And since none of these are going back in, I'm not going to worry about the order they come out. I'm going to be careful that I don't scratch up the bore as I'm coming out with the rods. Try to support that as it drops out. I'm going to rotate the crank just a little bit to give myself some room to push that out. Use the end of my hammer to just tap this rod out the bottom. So we're looking for, if you're looking for the history of the engine, look for cracked ring lands. The ring lands are the pieces of metal. These are your rings. It's your top ring, second ring, and your oil control ring pack. So you're going to look for any cracks or damage on the ring lands. Which this one has a decent amount of oil cooked up in there, but not seeing any damage to the piston. There's no pitting or marking on the top of it. Some tiny, tiny bits of scuffing up on the top here. Really not a lot of smeared material or anything. Wrist pin moves freely. It's all nice and tight. But yeah, no signs of catastrophic failure. This bearing looks as clean as the one on the top. So yeah, it doesn't look like this engine's really had a lot of trauma. So we're gonna pull out the other 5, see what they look like, and then we'll pull the crank out. So what I'm doing here, I'm laying out the pistons in the order they came out. So this is 1, 2, 3, 4, 5, 6. It's super easy on inline 6s. Everybody numbers them the same way, starting at the front of the motor to the back. With V8s, it's kind of a crapshoot depending on the manufacturer. They start on one side or the other. The numbering is a little goofy. I did notice one thing while I was in here, that whatever clown had this oil pan off before, look at this. You're not supposed to put any silicone on the inside of that O-ring. I mean, that really could have hurt the motor because that would have gone straight up into the oil pump. So this is where your strainer or your pickup for the oil pump goes. That O-ring is what's there to seal it. So you don't need any sealant on the inside of there. You run a bead on the outside to seal the pan. The O-ring seals the pan to the pickup, or the block to the pan. There's an O-ring or a gasket for the pan to the pickup. So all this schmoo on here just doesn't need to be there. So really, there's some just shoddy work on this motor before. But yeah, never ever do that because it'll get picked up by the oil pump, and that's not good for your motor. One thing to note, on inline 6, you're going to have 2 cylinders at top dead center at the same time. So 1 and 6, 2 and 5, and 3 and 4, so you can remove 2 at a time. It's super easy. And I'm just using a crescent wrench on the front. Rather than putting a bolt in and back it down, I can go either way with a crescent wrench. And I'm not putting a lot of force on it, so I'm not at risk of hurting this keyway. I'm just using a crescent wrench to turn it. One thing to note, since this is a GE motor, we don't have oil squirters. On a GTE block, the oil squirters would be on one side. I can't remember which side they'd be on. I believe, yeah, I'm not gonna lie to you, I don't remember which side they're on. But there'd be basically a bolt holding down an oil squirter that hooks up underneath the bottom of the piston to spray it with oil. They have a check valve in there that only opens over a certain pressure, but it sprays oil on the underside of the piston for cooling. If we were working on a turbo motor, this goes for most Toyota turbo motors, you'd want to remove those oil squirters before you pull the piston out because it kind of hangs out dangerously and you could clip it with the rod, or if you're trying to pull the piston out of the bottom, which you wouldn't be doing, you could bend it, but it's just safer to remove them all. You're going to want to take them apart and clean them anyway while they're out and blow them out. Make sure that the check valve's working properly and they're not full of old nasty oil. But that's a consideration, so you'd want to remove those, and I think it's a 5mm hex, socket head cap screw that's super easy to remove. Now that we've got all the pistons out, we're going to go and pull the crankshaft out. I already loosened one main cap just to take a peek. I'm going to loosen the rest. Before I try to pull it out, I got to pull the oil pump off. And as you remembered in the beginning, I pulled the rear end seal retainer out already, so there's nothing preventing us from lifting the crank out once we get the caps and the oil pump off. I'm just going to pry against the main webbing of the block here to get this oil pump off. It's just held on by sealant. So I'm going to zip them all off. And again, there's no order needed for these because the crank's not under any stress. If it were bent maybe, but that's an oddball scenario. So there's no order you need to remove these. And again, look at this. Why is there silicone there? Jeez. And again, just like the cam caps, these are numbered and they're indicated which way is forward. If you see there's a little arrow on the front here, the front end of that cap where the number is pointy. It's a little dirty, so it's harder to see the number. They're just numbered 1, 2, 3, 4, 5, all the way to 7. So you don't have to be super cautious when you're pulling these off. These bearings actually look reusable because there's no damage or marking on them. But we're going to do billet main caps on this block. So again, this is all not getting reused. I'll keep them with it just for the sake of it. Some machinists can take a peek. But again, these are super clean, not a lot of wear on this. All these are looking really tidy so far. No signs of wear, no dirt, no debris. Just a nice healthy engine. And as you'd expect, there's always a little bit more wear, generally on the front from the accessory drive and cold starts, and then on the rear. This one you can see there's a little bit of marking on the top of this bearing, or excuse me, the bottom of the bearing when it's installed in the car. It's just a little shiny here and here, but really nothing that would cause concern, and no marking or gouging on the crankshaft. Yeah, one thing you want to check, and this is something that I would normally do before I remove the main caps, is to make sure that your crank isn't bent. So it's pretty hard to bend one of these, but what you can just do is just spin it by hand while the main caps are still on it. Just without the pistons and rods, there's no drag from the rings. And you can see how nicely it spins, that there's no issues with this crankshaft. Look at that thrust washer. But again, these thrust washers are nice and clean, the crank's straight. And we can put a mic on it and air dial indicator, check run out if we wanted to. What you do with that is support it in V blocks, or you can use the block itself and support it in 2 bearings and measure run out on the different journals to see if the crank wobbles. But again, I had no reason to suspect this motor has lived an unmodified life. I'm going to throw this one on the shelf as a spare because we're doing a 3/4 stroker. So again, I'm using nothing from this build except the block. We're doing billet main caps. One problem with JZ motors is above, I'd probably say, anything past probably 600 or 700 torque, you run the risk of bending a rod, or beyond that, breaking the main caps. They'll break kind of on one side or the other where there's not as much meat. It's the stress. The pistons are firing straight into the crankshaft, and it'll crack this cap kind of through here or here, which is obviously not ideal. So there are half a dozen companies that make billet main caps. Now what you do is send them to the machine shop with the block, and what they'll do is take a line bore and bore out, because they add some extra meat on them, so it's a smaller diameter than it should be. They bore it out and then hone it to the correct size. one thing to note there is they have to do a lot of work. It will actually move your bearing center line higher up into the block. I know with some aftermarket, like with the Granite transmission swap, he gives you can get offset dowel pins. So you want to measure the centricity, not centricity, but the center line location, and measure the run out relative to the opening on the bell housing, so make sure your transmission's centered. That's something to note, is that if you do a lot of work on it, it may move the center line up, and if your oil pump is still located on the original dowel pins, you may have issues with oil pump alignment. So you can ask your machinist how much they had to move the center line of the crank, but something to pay attention to as you're doing this. One thing to note while I'm pulling it out here, this is people call it a thrust washer or thrust bearing. So the bearings in your motor, the main bearings, keep the crank located up and down, side to side, right? They're around this radius here. Same with the rods. And the rods, they're not trying to go to one side or the other, because that rod is straight. So the force from the pistons comes straight down in here, and your oil film here and the side of the rod kind of keeps it in place. But there's no forces acting front to back on the rod. On the crankshaft, however, you're going to have, especially with a manual car, your clutch release bearing, when you're pushing on the slave cylinder, it's going to force the crank one way or the other, depending if it's push or pull. It puts a considerable amount of thrust on the crank, and just locating the crankshaft in general, there's nothing keeping it fore and aft without your thrust bearings. So there's 2 in the top, 2 in the bottom on this motor. Some older designs, like some domestic motors, they'll have the thrust surface built into the main bearing. On Toyotas, it's a separate washer. But you can just check these. I've seen people even flip them side to side for wear. If they don't have any big scuffs or scratches, they'll just take the less burdened side and flip it to the other and put it back in. But something to pay note to, and make sure you never ever put a motor in without them. I've seen a motor come in that these were installed wrong. So the smooth side, the bare steel side, is going to go against the block, against this main journal here, or the main web. And you make sure that this is the bearing side with the grooves in there to collect oil. That's actually what's going to face the crankshaft. So make sure you don't flip that around. I've seen that done before, and they were lucky it didn't cause any damage, because it was run for just a little while before something else caused it to fail. But it didn't destroy the thrust surface on the block, because you can't. I've not seen anyone really fix that. Again, here's the other side of the thrust washer. Again, the side that looks like a bearing that has the grooves in it, that's a softer material, that needs to go toward the crankshaft. The steel backing goes toward this location on the block here. That's how those go in. I'm going to pull that so it doesn't get lost. One thing to look at while you're in the block, there's really not much to see from this side. Again, your oil squirters would be here, I can't remember which side on a GTE block. Make sure there's no odd marks on here from main caps moving around. If your motor's been really beat up, you might see some like material transfer between the cap and the block if things got rattled around quite a bit. But this thing, honestly, it led a pretty easy life aside from some sketchy service, all the extra silicone, but it looks pretty clean. I'm gonna look around for any messed up threads before we send it off for machine work, so we can tap those and clear them out. The engine shop there are gonna clean it up a little bit. On Toyota motors, on JZs, the 2 main oil galleys go through the full length of the block. So on one side, they're going to support all the oil squirters. If you look over on this side, this is the side that supports the VVTi, your oil pressure sensor, the oil filter goes on this side. So to do a proper job of cleaning these blocks out, what I'll normally do is I will TIG weld a steel rod to this ball bearing. This is just a ball. This is pressed into the oil galley on both sides. And so in order to get in there and clean it out, you have to remove these. I've seen people try to drill them out, but drilling out something that's a ball and getting it located and making a good hole in it is near impossible. So I'll generally just weld something to this, put it in a slide hammer, yank it out. Then you can use a long extension or rod and drive out the rear. And then you can actually replace those balls when you're done. Or in the past, I've tapped it for 3/8 pipe thread and put just a brass plug in there and sealed it up before I put it back together. But it is important to get those out so you can clean the oil galleys and get all the funky stuff out of there. Don't build a motor without that. And again, here's where our alternator stud would have been. That's why you remove it, because it's such a small ear, it's easy to clip that off and break it. But aside from that, it's pretty much ready to go to the machine shop. I'm going to throw the main caps back on it, give them the billet main caps with it and all the engine internals. They can machine everything and get it all spec'd out, and we're good to go. So I told you the story about seeing thrust washers in backward. That's not the only thing I've ever seen backward inside an engine. We had an MR2 I worked on that made, I think we had 530 on the dyno. Had great oil pressure. We fired it up, ran it in, threw it on the dyno, made some baseline pulls, and made 530, and then started knocking. And we're trying to figure out what's going on, so tear the motor apart, and the customer assembled the engine and shipped the car to us. We didn't assemble the motor, we provided the parts, the shop that I worked at the time, and he had flipped the main bearings. So this one was in the top, and this one was in the bottom. If you notice this hole here, that's something important to note. So if you put a bearing over that doesn't have a hole in it, that is your main oil feed supplying your bearings. And so your crankshaft, there are holes through that then feed the rod bearings. So we had a car that made 530 horsepower at the wheels on assembly lube only. It lubricated the head because the head wasn't blocked off, right? There's another galley going up to the cylinder head. But the guy managed to create a splash oiled bottom end because he blocked off all the oil feed to the crankshaft. So be really, really careful that when you put a motor together, these have these grooves on the back that allow for the oil to pass through the bearing into the crankshaft and through the crankshaft to the rods. Once you pop your bearing in, just as a dummy check, make sure you can see through that hole and see the oil galley. Yeah, so I just noticed something. It's been a while since I've seen the inside of a GTE motor. I've actually used GE motors for most of my builds because I'm not doing long enough pulls where I need piston cooling. We just run forged pistons with a little bit looser tolerances, but these are the pads where your oil squirters would be. So these would be machined flat, and there'd be a hole for the oil squirter and then an M6x1 threaded hole. Okay, so I'm going to do a few more things before we drop it off at the machine shop. It's close to the way I drop it off. Like I mentioned before, I'm going to weld a rod to this plug, yank that out with the slide hammer, knock the rear ones out, and then ask my machinist what he wants to do to plug these back up, whether he wants new balls from Toyota or whether he just wants to tap it 3/8. Again, anything messy you want to do before you send it off to machine work. Take a gasket scraper and get all this extra junk off. The cleaner a block is when you give it to your machinist, the more they're going to like you. And if you don't know now that you want your machinist to like you, then I hate to be the bearer of obvious news, but you want them to like you because they're always backlogged. They're always going to have other projects that need to get done. So the easier the project is for your machinist to get done, the prettier the parts are and the cleaner they are, the more they want to touch it. They don't want to get greasy and nasty. If you don't have a parts washer, brake cleaner works okay, but it gets expensive quickly. Oven cleaner works awesome for removing paint and grime. Foam it on, wear gloves. One of my buddies in high school in auto tech had the little arrow from the cap melted into his skin because it'll eat anything organic. So he had a little tattooed imprint of the oven cleaner button on his finger for a few weeks because he didn't know that he needed to wear gloves. But obviously do it somewhere with fresh air. If you need to wear a mask or respirator, please do. But doing it somewhere well ventilated, I'm not kidding around. That stuff's really bad for you. But yeah, to clean it off. After you clean it and degrease it, throw some WD-40 or light oil on it so it doesn't flash rust. And then, like I said, ask your machinist what he wants done before you get it to him. If he wants you to remove these or if he has a good process for it, then let him do it. Make sure you don't have any messed up threads, any broken bolts in there. You want to extract those because after you get a clean motor back from machining, you don't want to have to go welding on nuts to extract studs or do a lot of drilling and get shavings everywhere. You want to do everything before it goes to the machinist to make their life easy and make yours easy. You can get it, dust some paint on it, and assemble it, and you're good to go. Salem, read the sign. We're filming. Who's leaning into that? Yeah, some other things to talk about. Any loose studs here, you want to pull this guy, just bag it out, put it back in, because it doesn't need to be there while you're machining and painting the block. I still got a crush washer here that I need to pop off, and I'll spray some degreaser on, rinse it off, and get in there with a brush and start cleaning. I like leaving factory freeze plugs. I know a lot of machine shops make that standard. Toyota freeze plugs don't generally have issues. This block hasn't seen a lot of rust. It hasn't seen overpressurization of the cooling system. So I've got no reason to replace them because a lot of the aftermarket ones don't fit right and they're just going to pop out. I've seen more problems caused by aftermarket freeze plugs than they've solved. So if I can leave them in, I do. And it depends on your machinist and what their preference is. But again, I like Toyota parts when I can leave them. I only replace them when there's an obvious problem or we just exceeded their limit. But I'm going to clean up and degrease this. Chase all the holes out here for all accessories. I'm gonna remove this VIN tag just because it makes it hard to paint behind it. So I'll take a grinder and knock these rivets off and leave that blank. And then clean it up, degrease it, spray it some WD-40, throw it in a bag and take it to my machinist. All right, I'm gonna just knock some of this gasket material off here before I do anything more just because it's flaky and a little bit messy and I'm kind of annoyed by it. So it doesn't take a lot of force. And again, this is just the top layer of sealant they put on metal head gaskets. So I'm gonna get some of this off, and then I'll just do this first cylinder and we'll take a look at it. I don't know if this block has been bored. In fact, I haven't even really taken a good look at the bores. I know I'm gonna go at least a 0.5 millimeter over, so I'm not terribly concerned, but I wanna make sure there's been no catastrophic damage. You know, if you were not resurfacing this deck, you'd wanna be really careful with the razor and make sure you don't gouge or get debris scraped into the head gasket. And doing this in the car is a big concern because you're gonna drop debris down into the water jackets or in the cylinder or in your head bolt holes. So use your common sense. I've used in the past silicone plugs for powder coating. You can get them as a kit, and there's little silicone caps. You can pop them in holes to keep debris from getting down in them. And you'll find all kinds of uses for those, for protecting threads or blocking stuff off. We're ready to remove the oil galley plugs in the 2JZ block we've been working on. I spoke with my machinist. He preferred these plugs be removed, saves him the hassle. So what we're doing, use a MIG welder, you can use a MIG or TIG. MIG is faster. What we're gonna do, we've got these two basically ball bearings that are pressed in from the front. There's another pair in the back. Once these are out, we can knock the rear ones out with a long extension or piece of metal. But these, to get them out, there's nothing to grab onto. So what I'm actually using, I'm using a sacrificial tip of my slide hammer. So I'm gonna build up some weld on the plug, which serves two purposes. It gives me a bigger surface area to weld to, because these are actually really hard. They tend to fracture. So I'm gonna build up a lot of weld on here and then stick my little sacrificial tip to it. And that heats up everything, so it should move easily once I'm done welding. So again, if you got clean components here you're trying to keep clean, don't leave them in the block while you're doing this, since everything's getting replaced. I'm not worried as much about cleanliness, but I'm about to build some weld up, stick it on, and we'll slide her out. Ta-da! Alright, so we got the two front plugs knocked out. I thought I had a long enough extension to get to the rear ones. I don't. So I'm actually going to flip the block around to repeat the process for the rears once we get it off the stand and ready to go to the machine shop. But anyway, anything that's small enough diameter and round and long, they can go through that galley and knock out the rear plug. You can do it from the inside, or again, just repeat the process from the outside. If you have MIG welder, super easy, straightforward. Just use a slide hammer. You can make a slide hammer out of any piece of scrap, and piece of pull thread, whatever you got. You can get creative, but that's the solution I found that works best. Thanks for watching along. I know this has been a long video, but we appreciate you sticking with us. So what we've done, we wrapped up the full disassembly, inspection, removed all the extraneous nut bolts, studs, hardware, popped the oil galley plugs out. Basically made my machinist's life a lot easier. Dropped off the motor with him yesterday, so he estimated about a month as his backlog. So he's gonna deck the block, bore and hone the cylinders, machine it for new billet main caps. So he's gonna do a line hone to get those fitted, and then size everything up and get it ready to come back to us, and we'll shoot the dressing of the motor. I'm not going to assemble the short block. I'll leave that to him since that is his specialty. So we'll get a complete lovely short block. We'll probably have to paint the block, I would guess, when it comes back from him, and then I'll show you how to put a cylinder head on it, do an inspection, tighten everything up, and drop it in the car.